Hello everyone, welcome to CSE Core Concepts. In my series of searching and sorting, in my previous videos I have already discussed about selection sort and bubble sort. In case you have missed those videos, please go through those videos and try to understand the different types of sorting algorithms such as selection sort and bubble sort. In this video I am going to discuss about insertion sort. Insertion sort, as its name suggests, we are going to insert the element in a list. It is similar to that like a playing cards. When we play cards, I have a bunch of cards and if I am picking up one card and I am going to look in the bunch which I have and at the appropriate place we insert that card, right? So here also it is similar. We are going to divide our array or the list into two parts. One part is the sorted part and another is the unsorted part. And in each pass I am going to pick up one element from the unsorted sublist and move it to the sorted by inserting it in the suitable position, right? So if I am picking up one element from the unsorted part, I will look at the sorted part and wherever it fits in a sorted order, I am going to just insert that element. To understand this, let us assume an array having 10 elements. All are in an array is in an unsorted way. Now initial state is my ji is equal to 0. That means I will start from the first element. So my array of 0 is equals to 41. So initially when we do not have, we have only one list, right? Initially, which is an unsorted list. Now I have to create a sorted list from this unsorted list. So initially I will start with the first element whichever I am getting and I will assume it is sorted. So my sorted list has only one element currently, that is 41, and the rest from 11 to 38 that comes under my unsorted list. That is my first state, initial state. So this is what I am going to create my sorted array, right? So 41 is in a sorted position. Next time, I am going to pick up the next element from my unsorted list, that is 11. Now I will compare 11 with 41, right? And since 11 is less than 41, I will insert, that what makes it insertion sort. So I will insert 11 before 41. So my 0th element right now is 11 and the first element becomes my 41. Next element which I am going to pick up from my unsorted list is 47 and I am going to compare 47 with 11 and 41 both, right? Now since 47 is greater than 41, so I will put it after 41, that is at the second position. Then I will pick up the next element from the unsorted list, that is 65, and now I will compare with all the elements of my sorted list. Now I have 3 elements in my sorted list. Initially, I started with only one element, right? That is the first element. So now my sorted list is 11, 41 and 47. I am going to compare these 3 elements with 65 and of course 65 is greater than all 3 of them. So I will insert 65 at the third position. Then I will pick up the next element from the unsorted list, that is 20, and compare it with the first 4 elements. So my first 4 elements are, you can find out that 20 is less than 41, that is the second element, but 20 is greater than the 0th element, that is 11. So 20 will be inserted between 11 and 41, that is at the first position. This is what we say insertion. So we inserted 20 between 11 and 41, right? So since 20 has to be inserted at the first position, what I need to do here is that I have to move each element by one position to the right. Okay. So 65 was earlier at the third position. So now it has moved by one position to the right and now it has come to fourth position. Same way for 41 and 47. They also have been shifted by one position to the right. Then I will pick up the next element, that is 85. Sorry. So there is a mistake. 85 here. So 85 with the first 5 elements. and 85 is the greatest among them. So I will insert 85 at the fifth position. Then I will compare 110, that is the next unsorted element, from the first six elements. So 110 will be at the sixth position because it is greater among all the elements right now. Then I will pick up 56. Now 56 is what? Greater than 47, that is the third position, but it is smaller than the fifth position element, that is 65. So 56 will be inserted at the fourth position and one element will be shifted towards the right. Then comes your 74. 74 is again greater than 65 but smaller than 85. So 74 will be inserted at the sixth position and rest of the elements, that is 85 and 110, will be shifted by one position to the right. Then comes 38. Now 38, if you find out, it is greater than 20 but it is smaller than 41. So 38 will be inserted at the second position and rest all the elements will be shifted by one position. So you can see here all 10 elements are being sorted. Now understanding the time complexity. Now in this case, when you are taking up the first element in the sorted list, it requires no comparison because simply we just picked up the first element and we assumed it is sorted. So there were no comparisons being made. But from the second element, we required one comparison. When we picked up the second element, only one comparison had to be done with the first element. When we picked up the third element, we had to do two comparisons because the sorted list was containing already two elements. So we did two comparisons. So as you take one elements, the number of comparisons to be done is n minus 1. So total comparison is what? First element, no comparison, 0. Second element, 1 comparison. Third element, 2 comparison, and so on till n minus 1, which is O(n) square in the worst case. Worst case means it is a totally unsorted array. Okay, none of the two digits, none of the two elements, consecutive elements are sorted. So you have to go through them twice. So that is your O(n) square. But if it is a best case, then we can say that, okay, some of the elements were already in a sorted order and the number of comparisons did not require much swapping. Okay, so it can go for O(n) where the elements are in the sorted order. That means my array is already sorted. I am just checking, but I don't need to do any type of swapping. So I will go through the array only once, right? So it will come out to be O(n). I hope you understood about insertion sort. Please do practice on your own. Try to understand and please stay tuned for more such other sorting algorithms. And don't forget to like, share and subscribe to CSC Core Concepts. Thank you.